Now let us look at a few examples based on uniformly accelerated motion. Let's take the first example, which is a body starts from rest and moves along the positive x-axis. So there's a body that moves like this along the x-axis. It starts from rest, that means it's given that the initial velocity of the body is 0, u is equal to 0. So here's the body, let's say. And we are given that it moves with an acceleration of 2 meters per second squared, which remains a constant. It does not change with time along the x-axis itself, the positive x-axis. We are supposed to find out, number 1, the displacement of the body in the first 4 seconds of its motion, s in the 4 seconds, t is equal to 4. The next is we are supposed to find out the time when the velocity of the body becomes equal to 10 meters per second. And the third part is find out the displacement of the body s when this velocity is acquired by the body, when v becomes equal to 10. At that time, how much displacement has the body undergone? Okay, so we start with looking at the values that are given to us. The initial velocity is given, the acceleration is given, and for the first part we are supposed to find out the displacement in t is equal to 4 seconds. So if we are supposed to get displacement, do you see, can you just recall which equation helps us solve for s if we are given the initial velocity u, the acceleration a, and the time t? Which equation connects these 4 quantities? It's nothing but the second equation of motion, s is equal to ut plus half a t squared. If we just substitute all the values on the right hand side, we have u0 into t is given to be 4 plus half a is given to be 2 and then t is 4 once again, so 4 squared. When you solve this expression, you will get the answer as 16 meters. So the body would move 16 meters in the first 4 seconds of its motion. For the second part of the question, where we are given that the velocity acquired by the body is 10 meters per second and we are supposed to find out the time in which this happens. This time, for finding out the time when the final velocity is given, the initial velocity is given and acceleration is given, clearly we can use the first equation of motion, v is equal to u plus at, where v is given to be 10, u is 0, plus a is 2 times t, which we are supposed to find out. We can just solve this equation to get 2t is equal to 10 or t is equal to 10 by 2, that's 5 seconds. Now for the third part of the same situation, same problem. When v is 10, now we are supposed to find out the displacement of the body. So see that for this situation we know everything now. We know the initial velocity, we know the acceleration, we know the velocity at time t. We also know the time, 5 seconds. We have already found it. So we can either use the second equation of motion or we can use the third equation of motion. Both of them will work for us. So let's try using the third equation of motion. V squared minus u squared is equal to 2as. We know that v is equal to 10 meters per second, right? So we can substitute it here. 10 squared minus 0 squared is equal to 2. A is given to be 2 and we are looking for the value of s. So from here we can write 100 is equal to 4s or s is equal to 100 by 4, that's 25 meters. Right? Let's take another example. This time let us have a body which is already moving. So the question is like this: the driver of a car which is moving at 25 meters per second. So let's say this is a car and it is already moving with an initial velocity of 25 meters per second. The driver applies brakes that create a deceleration of 5 meters per second squared in the car. Okay, so as the car moves, a deceleration of 5, which means an acceleration of minus 5. All of you must understand this. Deceleration will slow the car down, right? So when we look for its acceleration, the rate of change of the velocity, The velocity is decreasing with time, so the change in velocity will be negative, and so will be the acceleration, right? So deceleration means acceleration in the opposite direction to velocity. So velocity is towards right, acceleration is towards left, and that is what we represent here with this minus sign. So it is given to us that the acceleration is minus 5 then, and we are supposed to find out number 1, the time taken by the car to come to a stop. Time taken when the car comes to a stop, that means the final velocity of the car becomes 0. So we are essentially supposed to find out t when v becomes 0. And for the as the second part, we are supposed to find out the distance traveled by the car during this time. Distance traveled when v becomes 0. Right? So here once again we can go through similar equations, just being careful about the sign of the quantities that we are going to put up. So a is minus 5, u we know is 25. For the first part of the question, part A, we can say that if the velocity has to go to 0 and we are supposed to find out time, we can get it easily from v is equal to u plus 80. v is 0, u is 25 plus a is minus 5 times t. So when you solve this, we will get t is equal to 25 by 5. That will be 5 seconds, right? For the second part of the same question, since we are looking for displacement now, as we know the velocities, initial, final, as all of them, we can use either the second or the third equation. Let's try using the third one. v squared minus u squared is equal to 2as will easily give us the answer here. 0 minus 25 squared is equal to 2 times minus 5 into s, the displacement. See that the minus sign on both the sides of the equation will cancel out, and we will have 625 as the square of 25. This is equal to 5 into 2, 10 s. So s will be nothing but 625 by 10, which you can write as 62.5 meters. Right? So this is the displacement of the car as it just stops under the effect of a deceleration. See how we are using the sign of the vector terms here. The acceleration being a vector, we have to be careful that we substitute its value along with the right sign. Only then we will get the correct answers. Let's take up another example now. This time there is a train that starts from rest and moves with a constant acceleration of 2 meter per second squared for 30 seconds. So for t is equal to, for first 30 seconds, a train which starts from rest means its u is 0, initial velocity is 0. It travels with an acceleration of 2, a constant acceleration for the first 30 seconds. This is the first part of the question. Then what happens is, this is the first part. As a second part of the question, now the brakes are applied. Once it travels for 30 seconds with 2 meter per second squared, now brakes are applied and the train comes to rest in the next 1 minute. In t is equal to 1 minute, which we can also write as 60 seconds, the train comes to a halt. That means its final velocity once again becomes 0. For the second part of the motion, they have not given us the deceleration with which the train travels. The acceleration is not given to us, but we are given the time that it takes to come to rest. And for the first part of the motion, we are given the acceleration and the initial velocity and the time. So be a little careful here. See that the train moves with 2 different accelerations in these 2 parts. In the first part, it accelerates from rest, reaches a certain velocity, and in the second part, it starts deaccelerating and then comes to rest once again. So we have to do this question in 2 separate parts, because in both the parts the accelerations are different, and if we try to use the equations of motion, we can use it only for that portion of motion where the acceleration is a constant, right? So what are we supposed to find out? We are supposed to find out, number 1, the total distance travelled by that car, S total, And secondly, the maximum speed attained by the train, V max of the train, is what we are also supposed to find out. There is another part of the question which asks you to find out the position or positions of the train at half the maximum speed, S, when the speed of the train is half of the maximum speed, V max by 2. Okay, so let us try and understand what kind of motion this is. So let's say the train started from a point A and it travels for the first 30 seconds and reaches a point B. From A to B, the initial velocity at A0, and from A to B it took a time of 30 seconds and it moves with an acceleration of 2 meters per second squared. Do we understand that by the time it reaches the point B, it will gain a certain velocity? Let's call that velocity to be V. Now at B, the driver applies the brakes and the train starts slowing down and it moves a certain further distance till it reaches the point C where it stops. So its final velocity, let's say V dash, becomes 0, right? So from A to B, the train accelerated, its speed increased throughout, and from B to C, the velocity, the speed of the train decreased throughout. From this figure, okay, one more thing that we know is that from B to C, the train took a time of 60 seconds. That's all that we know. Now observe that when we talk about the maximum velocity of the train, where will the velocity of the train be maximum, where its speed will be maximum? Do you all understand that it will be maximum right here at the point B? Because till the train reached the point B, it was accelerating. Continuously its speed was increasing. And once it reached B, after that it started slowing down. So that means the velocity that it gained by the time it reached B would be the maximum velocity of the train, isn't it? So we can call the velocity here as the V max. And we can easily find it out because you know the motion from A to B. We know everything about that motion. We know the initial velocity, we know the time, we know the acceleration, isn't it? So first thing that we understand here is that V max is over here, right at the point B. Second thing is, do we understand that when the train was moving from A to B, somewhere during the path it will encounter a velocity of V max by 2? As the speed is continuously increasing, we can call this as the point P, let's say, where the velocity becomes half of the maximum speed. And then do you also understand that during the second part of the motion from B to C, as the speed of the train decreases, once again it will reach a position where its velocity will be V max by 2, because now the speed is decreasing from V max to 0. Let's call this point as point Q. So in the third part of the question, we are supposed to find out the position of the point P, this point, as well as the position of the point Q, which is this point. Position maybe we can tell in terms of the starting position A, so we can maybe tell the distance AP, this distance, and then the distance AQ, this distance, both of them we can tell as the answer for the part C. So understand that part C of the question will have two answers, right? So let us proceed one by one. So for the first part of the question, for finding out the total displacement, we can find out the first displacement during the acceleration part AB, and then we can find out the second displacement during the deceleration part and can add the two, right? So for the first part of the motion from A to B, can we say the first displacement S1 can be obtained by ut plus half at squared? We know all the values here, just substituting the values will give us u is 0, t is 30 plus half, a is 2 meter per second squared and time is once again 30 squared. So when we solve all this, we will get this value of S1 as 1, 2 will cancel out and we will have 30 squared only as the answer, which will be 900 meters. So the distance AB is 900 meters. Next we come to the displacement S2, which is nothing but the displacement from B to C. For that, we know that the initial velocity at the point B. Now, okay, for finding out S2, we need to know the velocity at the point B, because nothing else except for the time here is given. So for finding out that velocity, we can once again focus on the part 1, the acceleration of the train, and we can also find out the velocity that it gains there. So V max at the point B, that is V is equal to U plus AT. See that we have written this equation for the first part of the motion, V is equal to U plus AT. This gives us the velocity at the point B as 60 meters per second. Understand that this V max is the final velocity for the first part of the motion from A to B, and it is the initial velocity for the second part of the motion. So we can use this V max as the U value for the second displacement, the initial velocity for the second displacement. So let's use it here. This will be S2 is equal to ut plus half at squared. Once again, if we have to use, we can say that this is equal to, okay, there is something else that we need to get here. What we need to get is the deceleration. We don't know the deceleration for the second part of the motion, right? So for that, what we'll do is, we'll once again use the first equation of motion along the direction B to C, right? So for that, we will have V is equal to U plus AT, giving us, see that for the second part of the motion, V is 0, final velocity of the train is 0, is equal to the initial velocity of the train is now 60 plus A into T. The time for the second part of the motion is 60 seconds, right? When we solve this, we will get the value of A here as minus 60 by 60, that is 1, minus 1. Minus 1 meter per second squared is the deceleration for the second part of the motion. This is what we have been able to obtain. And now we can substitute this value in the equation for S2. Let's get back here now. So for displacement of the second part, S2, U, the initial velocity is 60, into the time taken is 60 seconds, plus half, A for the second part is minus 1, we have just got this, and then once again 60 squared, right? So we can solve this to get the answer as 60 squared will be 3600. So 3600 minus half of 3600 will be 1800 meters. This is what we will get as the second displacement. So we have got the first displacement as 900, second displacement as 1800, and now we can write the total displacement S total as S1 plus S2, which will be 900 plus 1800, that's 2700 meters. If you want, you can also write it as 2.7 kilometers. So in solving the first part of this question itself, we have got to understand, or we got to know many values. We have got to know the maximum velocity of the train, right? We have also got to know the acceleration of the train during the second part of the motion, which is minus 1, right? So that we can use them for the other parts of the question now. Now the second part of the question is to find out V max. See that we have already got that. V max is nothing but 60 meters per second, which is the velocity at the end of the first part of the motion of the train. Now let us directly go to the third part of the question, which is to find out the positions where the velocity of the train is half of its maximum velocity. So let's do the C part now. This is the answer for the B part, V max. For the C part, we know now that V max is 60 meters per second, right? So can we say that for the first part of the motion, in the first part, we can use the third equation of motion to connect this V max with initial velocity U, which for the first part is 0, and the acceleration, which for the first part of the motion is 2 meter per second squared, right? And we are looking for that S, for which V is equal to V max by 2, that is 30 meters per second, right? So S is what we are looking for. Can we use the third equation of motion? Third equation of motion connects all these four quantities, U, A, V and S. So we directly use V squared minus U squared is equal to 2AS and substitute the values. So we'll have 30 squared minus 0 squared is equal to 2 into S, right? From here we will get S is equal to 30 squared, that's 900, divided by 2 into 2, that is 4. So this will be 450 by 2, that's 225 meters. Right, call it S1, the first position. This okay, let us call it S1 dash. We have already used S1 above. S1 dash is the first displacement of the train when it is at a velocity of 30, half the maximum velocity. See that this is the position of the point P. The way we have defined the point P in the figure above, it is this point where the velocity becomes half the maximum velocity, right? Now let us come to the other position during the second part of the motion. For the second part of the motion, we have the initial velocity as 60. The final velocity, once again we are looking for half the maximum velocity, that's 30 meter per second. We know that for the second part of the motion, acceleration is minus 1 meter per second squared, right? And for these values now we are looking for s. So once again, using third equation of motion, v squared minus u squared is equal to 2as will give us v squared minus u squared is equal to 2as. When we solve this, we will have 900 minus 3600 is equal to minus 2s, which is 2700 is equal to minus 2s, minus 2700, minus sign will cancel out and we will get s is equal to 2700 by 2, that will be 1350 meters, right? And understand that this is the displacement for the second part of the motion where the velocity is half of the maximum velocity. Let's look at this here. So what we have just now obtained is the distance BQ, because the second part of the motion starts from B. So the displacement that we obtained from this using this equation is the distance that the train travels from the point B till the point where its velocity becomes half the maximum value, right? So BQ is what we have got as 1350 meters. But we are looking for the distance AQ. Starting from the point A, we are looking for the distance of point Q. So we have to add to BQ the length AB, which is nothing but 900 meters. So we can say that S2 dash, the position of the second point Q where the train has half the maximum speed, will be 900 plus 1350 meters, that is 2250 meters, right? Which if you want, you can also write as 2.25 kilometers.